In this video, we are going to use a technique called completing the square to solve quadratic equations. And this technique is very useful because it's going to allow us to solve any quadratic equation. Before we start, we have to understand what a perfect square trinomial is. So let's take a look at a couple examples here. Here I have x plus 3, and I'm going to square it. So notice what happens to the terms as I multiply x plus 3 times x plus 3. This x times the 3 gives me 3x. The 3 times this x gives me 3x. So what I'm going to end up with on any time I square a binomial is two numbers in the center with the x term are going to be identical. And then they will add to give me the term that contains the x. Also, what's going to happen is the 3 times the 3 will always be squared to give me the last number. So what I'm going to find that for any sort of perfect square trinomial, whatever this number is, when it's in its factored form, this 3 times 2 will give me the x term coefficient, and squared will give me the constant term, the number. Okay? So let's see how that works again on another one that's got x minus 1/2 squared. So without even looking at all the work that I showed, I know that the minus 1/2 times 2 will give me the coefficient of x, or what would be b in ax squared plus bx plus c. So a negative 1/2 times 2 would be a negative 1. Well, here it is, right there, negative 1x. And the negative 1/2 squared would be the numbered term. So if I square a negative 1/2, that would be 1/4. And there's the 1/4. So let's go backward on this. So what we're really going to kind of use this for is looking at a perfect square trinomial and going back to its factors. So for example, if I had something that is x squared minus 10x plus 25, and let's say I knew that was a perfect square, then what I could do is take a look at this negative 10, and I know half that number would be what the binomial would be. So x minus 5 squared and the negative 5 squared would give me the 25. Okay, so let's take a look at how we use that. Now here's some introductory problems. And here's an example one. It says, okay, I have a trinomial x squared plus 14x plus c, and I want to find the value of c that would make this a perfect square. Okay, so I know that what I'm going to do is take this middle term, and I'm going to divide it by 2, and then I'm going to square it to give me the c, because remember, it's half the middle term is what the factor would be, so that would be x plus 7 squared, and then when I square the 7, it would give me the c. So c would be equal to 49. Okay, let's try another one. So I know the half the middle term squared is going to give me the c value. So c would be equal to half the middle term squared. There's half the middle term, squaring it, so that would be a negative 20. Squared would be 400. C will always be positive because I'm squaring a number. It will always be a plus. Let's do the next one. It would be half the middle term squared. So half the middle term So there's half the middle term squared. That would be a negative 3/10 squared, which would be 9/100. So C is equal to 9/100. So now let's actually use this technique of completing the square to solve a quadratic. And here are the steps that we're going to do. We want to make room so we can form a perfect square on this equation. Now, look, it cannot be factored, so I have to find some other way to solve it. Completing the square will work. The first technique is to take that 7 and move it to the other side. Okay? Now I'm going to add some value to both sides of the equation that will create a perfect square. So what I'm going to do is I'm going to take x squared minus 10x plus some value, we'll call it c, and we'll add c to both sides. And what I want to do is to create a perfect square on this side right here. So the value of c that I'm going to use would be half of a negative 10, that should be a negative 5, and I'm going to square that, so negative 5 squared is 25. So what I'm going to add is I'm going to add 25 to both sides. Now what I've done is I've actually created a perfect square on the left. So my next step is to take this left-hand side, which I've now created a perfect square trinomial, and write it in its factored form. So once again, that would be a negative 10, half of that, squared. In this case, it would be equal to 18. So what I've done is I've created a perfect square. Now we can solve this by taking the square root of both sides, and that's what I'm going to do. So I'm going to take the square root of x minus 5, and when I take the square root, I create a plus or minus on the other side. So I have x minus 5. Taking the square root of anything squared just pops that those numbers out, those values out. And what I'll have on the other side is, remember, 18 is 9 times 2. So I will have plus or minus 3 times the square root of 2, moving the 5 over. And I solved that quadratic. Let's try that again, a different problem. First step I'm going to do is to move the 5 over. Now I'm going to add some value to both sides. It's going to create a perfect square. And that value is going to be half of 18 squared. Well, half of 18 is a negative 9. Squaring that would be 81. Okay, so now writing the left-hand side as a perfect square. So that would be x, and half of 18 is 9. And on the other side, I'm going to have 76. Taking the square root of both sides. And 76 is really plus or minus 4 times 19. So what I would have is x minus 9 is equal to a plus or minus 2 times the square root of 19. And moving the 9 over, I get x is equal to 9 plus or minus 2 times the square root of 19. Okay, now let's see what happens when I have a problem that has a coefficient that is not 1 in front of the x squared. This has a 3. So I don't know how to take and find the perfect, or to figure out what the factors would be for something that has a coefficient in front of the x squared that's not 1. But that's not going to be a problem because I can just divide that coefficient off there. So my first step, when I have something that the number in front of x squared is not a 1, is I'm just going to take and divide the whole equation by whatever that coefficient is. I'm going to divide this side by 3 and this side by 3. And what that's going to give me now is I will have x squared plus 4x plus 5 is equal to 0. Okay, now what I've done is I've actually may end up with a fraction on this middle term. This one doesn't. So that's the disadvantage of doing this, is I could come up with some bad numbers in the center. But what I've done is I've gotten rid of the coefficient on the x squared and just made it a 1. So now we can go ahead and do completing the square. So I'm going to put x squared plus 4x and move the 5 over. So I need to find some value. Let's call it c. that makes the left-hand side a perfect square. And so that would be a half of a 4, which would be 2 squared. So that would be 4. And I have to add 4 to the other side. So writing the left-hand side is a perfect square. I would have x half the 4 is equal to a negative 1, taking the square root of both sides. So if I take the square root of x plus 2 squared, I get x plus 2, plus or minus the square root of a negative 1. X plus 2 is equal to plus or minus I. Moving the 2 over, I get a negative 2 plus or minus I. Let's do one more. Okay, so once again, you can see that I have a coefficient in front of the x squared that is not 1. So let's divide that out of there. Divide both sides by 2. I get x squared minus 10x plus 30 equal to 0. Now then I'm going to move the 30 over. And I'm going to add some value to both sides. It makes it a perfect square. So what that would be is half of the 10, negative 10. That would be a negative 5 squared. It would be 25. So I'm going to go x squared minus 10x plus 25 is equal to a negative 30 plus 25. So writing the left-hand side is a perfect square. So half of 10 is a negative 5. Taking the square root of both sides. And now simplifying. And moving the 5 over. And there I solved it.